In today's class and video, we are going to look at colorimetric analysis. So we'll start our introduction by looking at what colorimetric analysis is. So when we talk of colorimetric analysis, it's a method that is used to determine the concentration of a substance in a solution by measuring the intensity of its color. And basically, this is achieved by reacting the substance or the test sample with a color reagent to form a colored complex where the intensity of the colored complex formed is directly proportional to the concentration of the substance. And this method basically relies on the principle that the absorbance of light by a colored solution is directly proportional to the concentration of the absorbance species. That's from Beer-Lambert's law. So what you have to note is that we have three main practices of methodology or steps involved in this analysis. So the first is to prepare a suitable colored solution as your test sample. The second is to measure the light absorptive capacity or the amount of light absorbed by this test sample at a specific wavelength. And the third, which is the final step, is to determine the concentration of the test sample by comparing the amount of light it absorbed to that of a colored solution of a known concentration. So now let us look at how the methodology in the colorimetric analysis is carried out. So the first has to do with the preparation of the test sample, and in this case, a known reagent is added to the sample containing the substance to be analyzed. And the importance of this known reagent is to react with the substance in the test sample to form a colored compound. So once this is done, the second step is the measuring the amount of light absorbed by the test sample. And in this case, the intensity of the color of the test sample formed in the test sample preparation is measured using a colorimeter or a spectrophotometer at a selected or a specific wavelength. And the next step, which is the final step, has to do with the determination of the test sample concentration. And to do this, a calibration curve is prepared by using the known concentrations of the standard substance and its corresponding absorbance values of the color intensities. So once the calibration curve is plotted, the color intensity absorbance value of the unknown sample is compared to that of the standards in the calibration curve to determine the concentration of the substance in the sample. So let's look at what colorimetry is. So when we talk of colorimetry, is the science of measuring color. So the next is colorimeter. So the picture over here is a colorimeter, and this is the basic instrumentation or the basic parts of the colorimeter. So now let us look at what a colorimeter is. So it's a device that is used to measure the concentration of a colored substance in a solution by analyzing the amount of light that has passed through the solution or the amount of light absorbed by the solution. And the colorimeter works by passing a ray of light as shown from the basic instrumentation over here at a particular wavelength through a colored solution contained in a cuvette and measuring the amount of light absorbed or transmitted through it, as this allows for the calculation of the substance concentration based on Beer-Lambert's law. So now let us look at this question. So what is the difference between a colorimeter and a spectrophotometer? So the key difference is that A colorimeter measures the absorbance of light at specific wavelengths, typically in the visible spectrum, using color filters, whereas a spectrophotometer measures full spectrum of light, so that is the absorption and the transmittance, across a wider range of wavelengths, including the UV, the visible, and the infrared, using a monochromator. So in summary, the difference between the colorimeter and the spectrophotometer in terms of wavelength selection is that the colorimeter uses color filters. So this is the color filter over here at specific wavelengths of light, whilst the spectrophotometer uses a monochromator as shown from its basic instrumentation over here to select the desired wavelengths from a broader range of wavelengths. And two, in terms of the spectral range, the colorimeter is limited to the visible spectrum, and that has to do with the wavelength from 400 nanometer to 700 nanometer, whereas the spectrophotometer measures light in the ultraviolet range, the visible range, and the infrared spectrum. So this is the basic difference between the colorimeter and the spectrophotometer.